Hello and welcome back to our code-based analysis module. And today we're going to jump into our third and final hands-on session where we take the previously built report that we put together, the analysis around our suture defects, and refactor, or that is to say, improve upon our code base so that we can ensure that it's truly scalable. Now, there's a few things that we'll need to think about as we jump into this. We're actually going to have to start learning some new tools that will help us think about iteration in a more uh, well thought out and compelling way. And to start, we're going to pick up right where we left off. If you've been following along thus far, you should have a folder somewhere in your documents directory called something like Suture Quality Analysis. In our last session, we went through the process of creating an R project. There are some advantages to that we covered in the last session, but let's go ahead and double click on that project file and we'll see some of those advantages come to play right away. So now the first thing that we notice is that it preserved a lot of the state of our project, which can be really helpful. You will notice, however, that our environment tray is empty. And this is based on some of the settings that you may have in RStudio. As kind of a best practice, lots of times folks will set their settings so that the global environment isn't preserved. Basically, they will restart with a fresh instance of R every time they sit down to do some coding. This is important because it helps keep us from cross-contaminating our project work. We might end up in a situation where we create a variable in project A and then end up referencing it in project B. But if we aren't doing the kinds of periodic checks of restarting R from scratch and then compiling the entirety of our script, we might not be aware of this unexpected dependency. So one way that you can check for this, regardless of how your system's behaving with the way that you have your settings set up, is instead of just clicking Run All Chunks, we can actually click Restart R and Run All Chunks. What this is going to do for us is it's going to wipe out everything in the global environment, start us with a fresh R process, and then you'll see as it's kind of slowly starting to build, we get a progress bar right here kind of in the bottom portion. If we click on the console window, we can actually see what code is being compiled in real time. So we see we're loading our packages. If we were to scroll up to the top, we'd kind of see whereabouts we are. And we can see that our process is sort of rebuilding itself little by little until we end up exactly where we were when we last concluded. And that is with the creation of this Pareto chart that explores the defects that are troubling our half-inch circular needle project. And if we were to look at those, I'm actually going to zoom in just a little bit here to maybe make this a little easier for everyone to see. If we look at this, we can see that the three defects that appear to be the most problematic, or at least the most frequently occurring for this particular product, are a heat test failure, delamination occurring, or some sort of structural integrity check that's being failed. Now, in a real manufacturing environment, not a hypothetical case study, you would know exactly what each of these defect codes mean. These are kind of generated at a high level in a hypothetical scenario, so we can sort of define them however we'd like to. But we notice that, at least for this specific product, if we were to address those three things, we would address about 75% of all of the defects that occurred during our window of observation, which, if you recall from our previous lecture, is the month of February in the year 2020. So now we kind of need to go through this process of exploring how we can take what we have already built and rewrite our code in such a way that it is able to capture this same analytical insight regardless of the number of products that we're trying to process. You notice that when we took a look at our very first Pareto chart, we're actually not given really clear direction here. We can see that there are different defects occurring, and there are some that do occur more than others, but there's not really any clear wins. And so we might have a hard time prioritizing what defects we should go after for each product. That's why we introduced this filtering command filtered down to a specific product, and then reran that same analysis, that same Pareto chart function, with just this subset of our data to focus in on an individual product, and we see a trend present itself here. Now, we're going to need to do something similar, but I'm going to introduce a new function to you that can be pretty helpful. So again, I'm going to open up a new code chunk. Once more, that's the keyboard shortcut there is Control Alt and I, and I'm going to introduce a new function called split. And all that split does is it takes a table like this one, and it will split that table into smaller tables based off of a particular column that we provide. So to do this, I'm first going to just call the split function, and we could go ahead and look up the help documentation if we needed some additional insight. We can kind of see already that we get this little tooltip that pops up that says split x by f. So we're going to split our data source by our desired feature. I'm just going to type defect.df, and then I'm going to specify very explicitly which column I want to use for that split. And because we want an individual data frame focused on each product, I'm going to go ahead and supply defect.df $product as the second function. Now, we could run this, but we're not set up to store it anywhere yet. We haven't assigned this variable anywhere. So if I click run, you'll notice that I do get output. I get a bunch of these data frames, and if we look, we can actually see that the product does appear to change for each data frame, but I can't use these anywhere yet because I haven't put myself in a situation where I am storing these data frames. So in order to do that, I need to set up a place to catch them. And I am going to set up a new kind of object here. This is going to be defect. I'm going to specify that it's a split of the defect. And then I am going to put a .ls. Now, this .ls doesn't actually mean anything. We don't have to include that in order for a list to be built. I name it so that when I'm referring to it later, I'm aware that this is a list rather than a data frame, etc. But it's not like a normal file extension on a computer where anything that follows the dots actually tells the computer to do something. This is us just making our code more human readable. So now that I've specified where I want to store it, we need to do one more thing, and that is to bring in an assignment operator. You notice that we're actually getting this little X here on this line of code telling us that there's a problem. But if I introduce that assignment operator and give it a second to reparse, that X goes away, and we can now run this, and we'll see that the output disappears, but we also created a new object in our global environment. So let's take a moment to inspect this list. What do you notice about its structure? Looking into this, and we can even actually inspect it over in this tab as well, we see that this list has several different objects that are sort of components of it. And if we click into each of those lists, we actually see that this is basically a nested structure. I have a list called needle-1/2 circle, and that list has several items in it. It's got a record key, a product family key, or pardon me, a product family, a part number, etc. And then that list itself is a part of this bigger, higher level list. In many ways, we can think about a table as a list of columns. It is just a bunch of columns that are associated together in what we call a table, but we might choose to call a list. Now, the reason that this is important is because it gives us an opportunity to do what's called iteration or iterative programming. Rather than specifying the specific data frame, we can actually tell R to perform an action on each element inside of a list. And so to do that, we're going to come back to our original script here, and I am going to first bring in our original code just as reference. Just copying that from another document here. I mean, if I wanted to, we could scroll up and see it right here as well. But I'm just going to bring that code down, and then we're going to rewrite that code in an iterative fashion. And there's a few things that we need to do. The tool that we're going to use is called a for loop. It's called a for loop because we specify an individual unit in a list. So think of our for, we're going to say for each table in this list, perform some action. Now, the very first thing that we need to do is we need to set up something to store the output of our lists or the output of our process. And so I'm going to start by creating another list. I'm going to call it Pareto object.ls. I'm going to assign something to it, and I'm going to start by creating a vector, which is just a series or a sequence of things. I'm going to specify that I want that vector to be a list, and then I need to specify how long I want that list to be. Now, if I wanted to, I could just say 1, and if I run this code, I'm going to create that object, and we see that it's a list of a length 1. If we click into it though, there's nothing really there. We see null, this is another word for empty. We see that there's a length of 0, and we see that there is 1 object in here. That's fine as a basis, but it's not actually very helpful. Now, another thing that we could do is we could go and say, well, I remember from running the summary command of my product list that I have, it looks like about 9 different kinds of products. And that's potentially interesting as well, but the problem that that introduces is that it assumes that there will always be exactly 9 products. It could be that we decommission one of these items next month, or it might be that next month we introduce a new item, or even just that we start tracking defects for a new item, or that no defects occur for a particular item in a given time window. So doing this kind of approach is less elegant and puts us in a position where we are more likely to have to manually adjust our code in the future. So the way that I actually prefer to do this is to call a new function called length. And length can be really helpful because it will essentially tell us what dimension a particular object has. So if I call the length of our defect split list, I'm going to get back a value. And in this case, it happens to be 9. But because this is automatically splitting that entire data frame based off of the number of unique products or the number of unique values that occur in the product column, this will update based off of the underlying data set. And so we can actually, I'm just going to highlight that, copy and paste it in here. We can use that to specify our length. Now we kind of have 2 things happening here. I know it might be confusing because the word length is repeated 2 times. One of them is a function. Length with opening and closing parentheses is a function that evaluates to, in this case, the integer 9. This length is an attribute that we are defining that will be passed into our vector function. And that altogether is considered an argument. So some vocabulary there, but if you're going further in your learning of how to use programmatic analysis, some of those key vocab words will become important. So that puts me in a position where I can now run this line of code, and you'll notice that it updated our object, our Pareto object list, to have 9 spots in it. If I reopen it, you'll notice there's still nothing in them, but we've essentially created 9 buckets to capture things in. And that's usually kind of how we'll start thinking about iteration. Now, for loops have a certain sequence or a certain syntax that is a little bit different than what you might be used to. So we'll talk about them in parts. We're actually going to call a function called for. That's going to set up the for loop. Inside of that function, as its argument, it will take something that specifies what unit we want to evaluate and how many times we want to evaluate that unit. We'll get into those details in just a moment. But before we do, we then need to specify what we want to do for every iteration. And to do that, we actually have to use curly brackets, which we can do by holding down the Shift key and pushing the bracket key that is directly to the right of the P key. So I did this to start because this kind of gives us the skeletal structure of a for loop. Now let's go back and adapt this code for each thing. So we need to specify some sort of variable that is going to represent a single iteration. And it's kind of common practice to use I in this case. You can do many different things here, but I is sort of what you'll see in most of the documentation, so we're going to use that here. I'm then going to specify how many I's or how many iterations I expect to happen. So I'm going to use the keyword in, and then I'm going to call a new function that stands for sequence along. And basically, this is another way to count the length of something. And so I've got the sequence along function, and I'm actually going to pass to it this list. And what this does, one way that we can kind of spot check this is we can actually just highlight the specific code we want to run. And if we hit enter, we now see that we are building a vector for each individual item in the list that we've put together. In this long list up here, I'm going to collapse it down a little bit, but we have for each of these specified its index. Now this is really important because if you remember when we were doing selection of individual elements earlier, I'll scroll up so you can see the code that I'm referring to. When we were trying to specify exactly how to call forward a particular column, we said that doing it by name is usually the best practice. That's true if we know that that name is going to stay the same. But we can also use a dynamic index if we don't care about the order that something is processed in. What I mean by this is we can basically select from this list each individual data frame. And I'll show you how to do that here very briefly. If you remember, we can use those square brackets. And if I type a 1 in here, I'm going to print out a data frame that corresponds to the first item in this list. So I'm basically saying come down in from the root level and grab item 1, and we see that that is the needle with a 1/2 inch circle. You see that repeated here. I can also then specify a 2, and if I run just this line of code, we'll see that it's updated to be the 1/4 inch circle needle, and that matches our expectations here. This is really powerful because what this means is I've basically told R, hey, for each item in this list, I want you to do something, and I want you to start with item number 1, and then I'm going to have you do some operations to it, and then I want you to do item number 2, and we're going to do that for every single value in this sequence, which is 1 through 9, effectively applying our code to each individual item within that list. So this is how we set up kind of the iteration portion of it. We then need to spell out what we want it to do. And so there's a few things that we can do here. So if you remember, over here, we built a Pareto chart and we stored it in a variable. Here, we created some empty buckets to store our output. So let's start by calling this Pareto object, and we are going to store in the first sequence, but because we're going to iterate over this every time, we're going to use the variable that stands in. So this means the first time this loop runs, it will convert this to a 1 and store something in the first spot in this list. The second time it runs, it will convert it to the next value in our vector, which is a 2, and it will store something in item position number 2, and so forth. So we're telling it where we want it to store something. We're then going to use our assignment operator to effectively evaluate that piece. And then we can kind of start to borrow from the code we've already written. So now we know that we want to get the Pareto chart function in there. That was a typo on my part, so I'm just going to grab this Pareto chart and I'm going to copy that and I'm going to paste it down here. And then I know that I essentially want to grab the scrap code column of each of those individual data frames. So very similar to what we did here, I need to set up a similar iterative cycle. So I'm going to call my list. Now, if you remember, the list that actually has our data in it is called defect_split.ls. I'm then going to introduce a selection tool and tell it that I want to grab the nth, or whatever value I has taken from this list of values here. And then I can even specify on top of that which column I want it to grab, which we know is scrap code. Now, if I just ran this, this should essentially build a Pareto chart for each item in it. So let's run that, see if we get any errors. You'll notice that we're still calling this particular piece, so we can comment that out if we want. We won't see that output. And now if we come into our Pareto objects, and if we reload this section, sometimes you need to do that when you make a change to an object when you have it in the viewer. Let's come to our Pareto objects, and we can now see that we don't have null values here anymore. We actually have the data associated with that Pareto chart. And if we come into the plot environment and P, this is everything that's needed to draw the graph that we were discussing. So I'm going to close that up, and I'm going to show you very quickly how we can use another for loop. I'm just going to create some extra space here so that code's a little more centered. I'm going to show you how we can use another for loop to very quickly print out those charts. Now there's, again, it's that same format, so we're going to type for, and we're going to then introduce our curly braces. We're going to come back in here and say for each iteration in, and this time I'm going to use sequence along the new list object that I just created. I'm saying essentially for each of these objects, 1, 2, 3, 4, 5, 6, 7, 8, 9, I want you to do something. And then I'm going to specify what I want it to do between these curly braces. And this is actually really simple. I want it to print out that chart. And we haven't really worked with the print function yet. It's a pretty basic one. All it's going to do is display on our screen something that we want. And in this case, we want to grab the nth iteration of everything in that list that we just created. And if you remember, the default for when we call P, when we call the result that this generates, is that graph. So I'm going to run that here. And you can see that it generated a graph for each individual product. Now there are some things we need to do to improve this, but we're well on our way to building something that's helpful. Now, one thing we can do right off the bat is we can actually introduce a couple tags that will help us change this display, and we can decide if we like this or not. We can specify that we want to hold our figure show variable, or our figure show tag, and we can specify that we want the output width to be 33%. And what this does is it's going to change this display when we knit this document to display, instead of a long list of each of these variables, we're actually going to find ourselves in a position where we build them in a grid. So now we actually do see that we have a particular issue that we'll have to address here, and it's up on line 13. That's probably when we're calling a particular package, so we can kind of try to troubleshoot that in real time and see what's happening. That is because we're still trying potentially to install this. So that's a good catch. We're actually going to comment that out because we don't need to install that package. We've already done that. Let's try to knit that one more time. And let's see what kind of output we get. Just going to give that a second to compile. And now we can start to see the outputs of everything we've done. Now, we haven't really written a lot of prose in this report. So that's something that in the real world we would need to go and clean up, but we can see that we're able to generate, and this is that grid I was telling you about, we're able to generate things in a report where we could pretty easily include some analysis. So I'm going to come down here, and just to show you what the difference is, I'm actually going to remove these flags, and you can kind of decide what you like better. I actually think that there might be a pretty strong case for not displaying this in a grid. It makes things pretty hard to read. But we'll see what the output looks like, and you can kind of determine what you like. So we're just going to wait for that to compile one more time. And if we come down to the bottom, now we can see a much more legible version of the graph. Now, like I said, we could include some prose in between these code chunks, that is definitely a conversation worth having as we start to explore how to effectively communicate using these tools. But I think before we get too far ahead, there's actually some things that I want to do to clean up this output. Now, one thing we notice is that there were no joint separations or structural integrity errors with whatever our last iteration was, or our last project evaluated. And so we need to try to troubleshoot that. We can also see that this title doesn't really help us, and there's no labels. So let's come back up to our code here, and let's actually try to introduce some things. Now, the first thing that we might notice is that if I were to just do what they call hard coding, if I were to write out this title, it's not going to update itself in a way that's very effective for us, because I don't know, or at least I should say, my script does not know what the product is in each place. It only knows what index that product takes up, or what position it takes up in that regard. So we can do a few things to try to help address this. One thing we can do is just introduce a title. I'm just going to quickly get us in a position where we have a title, and then let's also go ahead and introduce some of the things that we were working with before, which was a Y label, and I believe we also had an X label, and I see that I actually put my parentheses, or pardon me, my comma on the wrong side of that parentheses. So if we do this, we'll get that code to display more appropriately, and it understands what we're trying to do. So just as we had before, we're going to call this the frequency, and then we're going to introduce an X label, and we're going to call that the defect code. And now we're going to go ahead and run this, and we'll see if it's improved. So I've just built them, and now I actually need to run the second code block, which will print them. And we get a title. It's not very helpful yet. We get frequency, and we get the defect code. So now the question becomes, how can we write our title in such a way that it is dynamic? Now, part of this can be answered by looking into each of these lists here. When I expose this, I can see that I do in fact have the product encoded here as a factor. And if I can, instead of reaching down a single level to grab this whole data frame, if I can reach down and grab perhaps the first value of that product column, it would essentially be the same thing as grabbing this cell right here. That would put me in a position where I could dynamically introduce that title in a way that makes a little bit more sense. So to do this, I'm actually going to use a new function. This function is called paste 0, and paste lets us concatenate things together. Basically just means take strings and set them one right after the other in ways that we can build sentences. You can also do this with lots of other things, but that's what we're going to use it for first. So I'm going to first type paste 0 to call that function. Paste 0 takes a list or a collection of individual units and pastes them out together. So for instance, I could say paste hi, paste world, and if I just run this paste function, we should then get the output like this, hi world. So we can do a few things here. Now, so we're using the combined function. This is something that was introduced in the very first lecture that we had together. And what I need to include or incorporate here is, first, I want to grab, I'm going to try to mirror this title. So I need to grab Pareto analysis defects. I've actually got that written off screen, so I'm just going to paste that in there. Then I need to introduce a string version of the thing that I'm trying to capture. So if we remember, let's first do the selection. I need to grab the defect split. I then need to grab the very first, well, I guess it's not the very first, whatever the nth iteration is of that particular data frame. So in this case, I'm saying grab data frame, if I is equal to 1, grab data frame 1. If I is equal to 2, grab data frame 2. So I'm going to call that into place. And then I can use the exact same things that we had done before, and I can just say, grab me the product column. Now, if I run this, I'm actually going to get just the whole product column, which is not what I want. I want the first value of the product column. Because I know that they're all the same, there is no variation in this product because that is how we filtered our data. I can do one more thing and grab the first value of it. And now I'm in a position where I am able, let's just actually call that as a 1, and then let's run this one more time, and you'll see what we get as an output. We just get that single item. But you'll notice there's an issue we run into, and that's this is coded as a factor. So it contains this additional information about the levels. Now there is a way that we can address this, and the easiest way to address it is to just wrap this in one of our previous functions that's going to convert it into a string. And previously, if you remember, we did as factor as a function. We can reverse that change by doing as character and then calling that function like so. And if we now were to run this function, we get just a single character that is the product name. And if we change this to 2, we'll get a different product name. So let's do that here. That should be the 1/4 inch. So I do need to remember to come back and convert this into an I, but that puts us in a position where we've basically built out our previous title. We've said Pareto analysis defects : then we've included this circle, and we can repeat this same style of selection using our dates. Now, in this particular instance, our dates are exactly the same. It would probably be most appropriate to set up this same kind of approach with each of our dates. I, for the sake of simplicity, am actually just going to bring our dates in a more regular fashion. And so to do that, I just need to put in a comma there. I'm going to hard code our dates. Again, that's just simplicity during our example. We would really want to recreate this same kind of logic to harvest the dates for each of those columns, which isn't actually terribly challenging to do, so it may actually be worth doing as well, but maybe that's the bonus opportunity. Go and actually code that into your same script using this exact same piece. You would just need to change this product column to reflect the other elements. Now there's one last thing that we need to do here, and that's we need to include, we're going to pass in an argument called collapse, and this basically tells it how to separate each of these pieces. What do we want it to put in between Pareto analysis and between the dates, and that's just a space. So now if we run this, and then if we run our print, we should get a title that makes a lot more sense to us. And we can see that play out right here. Now that puts us in a position where we can ultimately do the exact same thing that we've done with this print function, but call the data field as well. And if you remember, we did that previously by, instead of just calling the first item in that list, we actually specified that we wanted the data. So we can do that here really simply by just typing in that print function again. We're going to call it on our Pareto object list, and then we are going to specify that we want whatever the appropriate iteration is, 1 through 9. And then we're going to use that same $sign and say we want the data. Now when we print this, we're actually going to see a few things happen. We get both the data frames and we get the graphs that help us identify some things. Now the last thing that we need to address really quickly is that some of these things don't have particular instances of a given value. Now that comes because of the fact that when we coded this in, we passed it a factor instead of a character. So we can pretty simply take this same Pareto chart, and we're going to do exactly what we did with this object, and we're just going to call that as character function on it. So let's go ahead and do that. As, had a typo there, character, and this will convert this factor back into raw characters. We're doing it right here because that's something that's unique to the Pareto chart function. Not unique, but specific to it. And if we now run this, and then run this chunk of code as well, we should see that we end up with a different number of X values, meaning a different number of columns based on how many factors, or pardon me, how many defect code types were actually reported. So we noticed for the 4-aught suture, we only have 6. But if we come over here to the 2-aught suture, it looks like we have more than that. In this case, it looks closer to, what is that, 2, 4, 6, 8. And we may have some instances where we actually have all 9. So that is how we start to build this iterative report that can be particularly powerful. One of the things that is a little bit tricky here is we don't know how this is going to compile yet. So instead of just treating this code here, let's actually knit this document, wait for its output to take place, and once we get that output, you'll see that we should have something that more closely resembles the kind of report that we might be looking for, where for each individual object, we're given the chart and then the detailed explanation of it in terms of its numerical representation. Now, if we wanted to take this in even further, we could actually add some print statements in here into this for loop that contained prose, or we could pepper prose throughout this document. That's all a perfectly valid way to approach it. The thing that's so powerful about this, though, is that this scales, these most recent blocks of code that we've written, scale just as well for 2 products as they do for 2,000. Now, the processing time is obviously going to increase when we end up with 2,000 different products, but the code in the report will still run and process effectively. Now, we haven't quite built a full report here. We've really just done the analytical portion. That's largely because that's the scope of this particular module. But we could definitely dig into how we should effectively communicate with our stakeholders what they need to do. And if we take this back to our business case, we are able to identify where our manufacturing director should focus her resources per product. For instance, for the 1/4-inch circle needle, we can see that if she focuses on structural integrity, heat resilience, and avoiding joint separations, she would effectively address 80% or so of each of the defects that are occurring for that product. But importantly, if we dive into this other suture, we can see that it's more focused on critical value failures. Now, that wraps up our session for today, but that should put us in a position where we can start to generate these iterative reports. You may find too that a different format becomes more appropriate. For instance, instead of an HTML document, you might choose to dump all of this into some kind of directory where you're storing PNGs for the graphs and CSVs for the data, and then building reports that way. Or, if we were really going to get serious about this, we might want to get into building a Shiny app dashboard. But this provides a pretty firm introduction to the processes. I really wish you well on your learning path for programmatic analysis. And if there's anything else that I can do to be helpful, please feel free to reach out. Thanks.